Hi all, welcome to Go Classes. Let's start the discussion of today's DPP. Before we start, please let me know audio, video, volume, everything is fine. Audio, video, volume, echo, everything is clear, everything is fine. Let me know. So let's start. Hi all, welcome to Go Classes. So today's DPP is Discrete Mathematics. The topic is first order logic. All the questions are taken from Stanford University. Welcome to Go Classes GOAT DPP series, basically our YouTube DPP series for GATE CS, GATE DA. The complete GOAT DPP series, the complete playlist link you can find in the description, also in the pinned comment. All the questions in our YouTube DPP series are taken from standard resources to ensure that you practice top quality questions. On YouTube, you can search GATE CS DPP, and then this Go Classes session, this DPP session will basically will be shown by the YouTube. Okay, so you can just search this GATE CS DPP, and here you can notice that this link you can find here, the GATE CS GOAT DPP series, the complete playlist link. This is the link, you can click it. Okay, so just search GATE CS DPP, and then you can find this playlist link, or you can just check out the pinned comment, also the description. You will find the GOAT DPP series, the complete playlist link. Okay, this is the playlist, you can check here. So you can see DPP day 5, day 6. Okay, question, solution, like that. This is today's question. This is taken from Stanford University, and this is a beautiful question. It will be like the complete revision of first order logic. Now, remember, similar question based on the same template from Stanford University, similar question we have done in the previous DPP also. So in this playlist, you can see in this GOAT DPP series playlist, basically our YouTube DPP series playlist, here, if you notice, this day 6 DPP, if you notice, this also has question from Stanford University based on same template, same type of question. Okay, but a different question based on the same template. So remember, this previous DPP that we have seen, that is also based on this same template, right? Yes or no? And I told you that in the Stanford resources, there are many questions based on this template. There are many different questions based on this template, and each and every one of those questions we are going to solve. So remember, the previous DPP, similar question we have done. Today, similar question we are doing. And remember, in the future DPPs also, maybe alternatively, but in the future DPPs also, you will find similar template questions from Stanford University, from first order logic. Okay, this is a very good question, beautiful question. And in the GATE exam, so far this type of question has not come. Maybe this type of question can come in the future. So we are going to solve each and every question based on this template from the Stanford University in the future DPPs also. Okay, so let's solve this question. Let's read this. The question is saying that this diagram is given to us, and these are people A, B, C, D. These are 4 people. So you can see the diagram to the right represents a set of people named A, B, C, D. If there is an arrow from person X to person Y, then person X loves person Y. We will denote this by predicate loves XY. So this predicate loves XY, this means person X loves person Y, and that means in the diagram, in this diagram, there is a direct arrow from person X to person Y. Below is a list of formulas in first order logic about this picture. And in these formulas, what is P? The letter P represents the set of all people. So remember, this P represents this set of all people A, B, C, D. For each formula, determine whether the formula is true or false. So notice one thing. In these formulas, what is this P? For example, you can see here X belongs to P. You can see Y belongs to P. So these variables X and Y, they belong to P. But what is P? P is basically set of these 4 people A, B, C, D. So the domain is basically Domain contains only four people A, B, C, D, and every variable points to that domain. Variable X, variable Y, they basically refer to that domain. Correct? So this is the question. I hope you understood. Notice one thing here. From A to C, there is a direct arrow. So I can say that A loves C. But remember, from C to A, there is no direct arrow. So C does not love A. Correct? Also notice, from D to D, there is no direct arrow. From D to D, there is no self loop, there is no direct arrow. So D does not love D. A does not love A. B loves D, but D does not love B. Correct? You can notice D does not love anyone. D does not love D because there is no self loop. So D does not love D. D does not love A. D does not love B. D does not love C. Because there is no arrow, there is no direct arrow from D to anyone. So D does not love anyone. Can I say A loves everyone? What do you think? Tell me this statement. Can I say A loves everyone? What is the domain here? Notice the domain has four elements. These are the four people A, B, C, D. So domain is basically P and A, B, C, D. So tell me, can I say A loves everyone? You can see A loves B, A loves C, A loves D because from A there is direct arrow to B to C to D. But remember, A does not love everyone. When I say A loves everyone, it means I am talking about the domain. Can I say A loves everyone in the domain? Think about it. Can I say A loves everyone in the domain? No. A does not love A. There is no direct arrow from A to A. So remember, A does not love everyone. And you can see D does not love anyone. A loves three people. A does not love A. No one loves themselves. Yes or no? A, B, C, D. None of them is loving themselves. So I hope you understood. Now let's solve all these questions one by one. So let's see the first one. Pause the video and tell me the answer. What do you think? What is the answer? This first order logic expression, is this true or false for this diagram? So let's solve it. You can see we are saying for all x, for all y. What is P? You already know that P is basically domain, and that contains four people A, B, C, D. So domain contains four people A, B, C, D. This is the domain. And we are saying that X belongs to P, Y belongs to P. And you can see here we have the template for all, for all X, for all Y. What it means? It means that for every pair of element in this domain, those two elements can be same or different, correct? X, Y, they can be same, they can be different. For example, X, Y both can be A. X can be A, Y can be B, X can be B, Y can be A. The point is for all, it means for every pair of elements from this domain, those elements may be same, may be different. But for every pair, what we are saying, you can see for all X, for all Y, we are saying X loves Y or Y loves X. So tell me, whatever two elements I take, can I say that X loves Y or Y loves X? Means at least one of them loves the another. Can I say? You can see if I take AB, then A loves B. Means, see here, this first statement, let's see the English interpretation. The English interpretation for this first statement, that is that for every pair XY, okay, where X belongs to P, Y belongs to P, right? So you can see where X belongs to P means X is in the domain and Y is in the domain, correct? Okay, so you can see that where X belongs to P, Y belongs to P. Now we are saying that for every pair XY, either X loves Y, there is a direct arrow from X to Y, or there is a direct arrow from Y to X. Means at least one of them loves the another, or maybe both. Both is also fine. If both love one another, that is also fine. So you tell me, if I take any two elements, for example, if I take AB, then you can see A loves B, AC, A loves C, AD, A loves D. If I take BC, B loves C, BD, B loves D. If I take CD, C loves D. So it is looking like that, yes, whatever pair of elements I take, at least one of them is loving another. But you forgot about a corner case. What is that? What if x and y are same? What if they are referring to the same person? Because remember, x is also referring to this domain, y is also referring to this domain. X and y, they can be same, they can be different, they can refer to same person, they can refer to different person. Correct? Yes or no? So now you can notice, if I take x and y to be same, because remember one thing, that this statement is saying that whatever pair of elements you take, those elements can be same or those elements can be different. For every pair of elements, it should happen that at least one of them is loving another. But you can see, if I take x equal to a and y equal to a, means if both x and y refer to the same element, then you can easily see that, because there is no direct arrow from a to a, so a does not love a. So if I take x a y a, or if I take x b y b, or if I take x c y c, I can take x d y d. Basically x and y, if they refer to the same element, then you can easily see that this will become false. Correct? Yes or no? Now here you can see that loves a or loves a, this this will become false. Correct? This will become false. Okay, so you can see that this first statement has become false. I hope you understood, because the first statement is saying that for every pair of elements, those elements can be same or different, but for every pair of elements, it should happen that either x loves y or y loves x, or both. But you can see, if I take x and y, both if they refer to the same element, then you can easily notice that this loves xy or loves yx, this will be false. So I can say that the first statement, this is basically false. I hope you understood. And for the first statement, what is the counter example? You can see counter example is xy equal to a or bb or cc or dt. These are the counter examples. So you can see the counter example here. Let me write what are the counter examples. So the counter examples are basically that, if I take xy to be aa or bb or cc or dd. These are the counter examples. I hope you understood. So this is the complete analysis. Now, from this, what did you understand? One thing. Tell me, what one thing you understood from this question? This is a beautiful question. The reason is that here, this corner case, don't forget about this corner case. Okay, so you can write a note here. This is an important question, remember. Okay, so you can write a note in your notes. You can write a note that don't forget the corner case. Don't forget the cases where x and y are same, means they are referring to the same element. Okay, I hope you understood. So you can write this note in your notes, because maybe in the future, maybe you can miss this corner case. You can miss considering x and y referring to the same element. If you miss it, then definitely you will mark this first statement true, but actually it is false. Okay, now let's see the second statement. The second statement is saying for all x, for all y, means every pair of elements, those elements can be same, those elements can be different, but for every pair of elements, what should happen? You can see, if they are different, then x loves y or y loves x. Now notice, we are saying if they are different, then at least one of them loves another. Correct? Yes or no? So notice one thing, this second statement, what this is saying, it is saying that for every pair, for every pair xy, for every pair xy, we are basically saying that whatever pair you take xy, if x and y are different, then at least one of them loves another. X loves y or y loves x. Correct? So this is the point. Now you tell me, is this statement true? That whatever two elements I take, if they are different, I only care when they are different. If they are same, I don't care. This statement is implication statement. Means if LHS is true, then RHS must be true. If x and y are different, then definitely it should happen that at least one of them is loving another. Yes, this statement is actually true, this second statement, because if I take any two different elements, at least one of them is loving another. Whatever two elements you take, for example, if you take CD, then you can see C loves D. If you take BD, B loves D. if you take BC, B loves C. If you take AD, A loves D. Whatever two elements you take, if they are different, then at least one of them is loving another. So definitely this second statement, this is actually true. I hope you understood. So this second statement is basically putting this condition that for every pair X and Y, remember X is from the domain, Y is from the domain, but we are saying that for every pair X and Y, if X, Y are different, then at least one of them is loving another. Yes, this statement is true. So very simple. Let's see the third statement. For all X, for all Y, means for every pair of elements, what we are saying? We are saying that if they are different, then X loves Y if and only if Y does not love X. Let's see this. Here you can see this is for all template, right? So I can say that this is basically saying that for all pairs X and XY, X belongs to the domain, Y belongs to the domain. For every pair XY, we are basically saying that if X and Y are different, then what should happen? Notice, then what should happen? Then it should be true. Loves XY if and only if, this is if and only if, you can see. When the if and only if will be true? If and only if will be true if both of these are true or both of these are false. Correct? So you can see we are saying if X and Y are different, then remember either it will happen or it will happen. Means either this and this both are true or both are false. Okay, so I can say that either, you can see either X loves Y, this is also true, and negation of loves YX means Y does not love X, or both are false means X does not love Y, means X does not love Y, and this is also false, it means Y loves X. Okay, this is what the question is saying. I hope you understood. So notice one thing, we are saying that for every pair XY, for every pair of elements, those elements can be same or those elements can be different, but for every pair of elements we are saying that if they are different, I only care when they are different. So I will only consider those pairs where I have different elements. So remember, if they are different, then what should happen? X loves Y if and only if Y does not love X, because there is a negation here. Correct? So you can see that either this will happen if X and Y are different, then X loves Y, Y does not love X, or X does not love Y, Y loves X. Basically, if X and Y are different, then there must be one-way love between them. Can I say? Do you agree with me? There must be one-way love between them. Either X loves Y, then Y does not love X, or Y loves X, then X does not love Y. Basically, this simply means that between different people, we are simply saying that between different people, there must be one-way love. Not two-way love. There must be one-way love. Not two-way and not no way. Okay. Neither two-way nor no way. So remember, there must be exactly one way. This is the statement. Now you tell me this statement is true or false. If I consider different elements, then yes, there is one way love. Whatever two different elements I consider, if I consider AB, you can see A loves B, B does not love A. You can see if I consider AD, A loves D, D does not love A. Whatever two elements you can consider, CD you can consider C loves D, D does not love C. You can consider BD, B loves D, D does not love B. So you can see here whatever two different elements you consider between any two different people, you can see between any two different people, there is always a one way love here. Yes, so this statement is true. This statement is true. I hope you understood. Okay, so here actually I can say between every two different people. Between every two different people, there must be a one way love. Yes, this statement is actually true. I hope you understood. So far we have seen three statements. Tell me, when you solved this question on your own, when you tried this DPP on your own, by your own, when you tried, then so far in these three questions, did you do all of them correct? What do you think? Let me know. So far in these three questions, did you do all of them correct? How many of them did you do correct? How many of them did you do wrong? Let me know. Means so far out of three, how many marks you will give to yourself? Let me know. Let's solve the fourth statement. Let's see whether this expression is true or false for this diagram. Here you can see the template is there exist for all. We have this template, there exist x for all y. Remember what is P? Domain is P. Domain is P, and that is basically ABCD. It contains four people ABCD. Now you can see x and y, they both refer to the domain. Correct? X also refers to the domain, y also refers to the domain. These are the variables which refer to the domain. So now here the template is there exist for all. What this template actually means? You know, this template, this simply means that this is the domain of x, this is the domain of y. This template simply says that there is at least one fixed element there exist for all, means there is at least one fixed element. This is a fixed element, at least one fixed element. Okay, so you can see there is a x, so there is a x such that for all y, means there is at least one fixed element such that for all y, with this fixed x, you take all y. Okay, this is the point. Now for all these pairs, this must be true. Okay, so here you can easily notice we are saying that there is someone, there is at least one fixed person such that for all y, x loves y. So can I say there is at least one person here who loves everyone? Tell me. The answer is no. You can notice A loves B, C, D, but A does not love A. Remember, the domain of X that contains A, B, C, D. This is the domain of X. And the domain of Y that also contains A, B, C, D. X and Y, they refer to the same domain. So here you can see this is the domain of X, this is the domain of Y. And this statement is saying that there is at least one fixed person who loves everyone. Correct? So here you can see loves X, Y. Okay, so here notice one thing, that A loves B, A loves B, A loves C, A loves D. But you can notice that A does not love A. Okay, similarly, you can notice that B loves C, B loves D, but you can see that B does not love B. Correct? If you see this, B does not love B, B does not love A. Okay, so whatever element you take here, whatever fixed element you take here, with that, if you take every possibility of Y, then you will see that with at least one such possibility of Y, this statement actually will be false. So basically what I want to say, I want to say that this statement is false. What this statement is saying, this is saying that there is at least one person who loves everyone. There is at least one X, there is at least one person such that for every Y, X loves Y. So I can say that this statement basically says that there is at least one person who loves everyone. Someone loves everyone. But someone loves everyone, this is actually false, because when I say someone loves everyone, then it also means that this someone should also love himself, herself. Correct? So this is actually false here. This is actually false here. I hope you understood. So the fourth statement is actually false. Okay? Very simple. So here some students might be thinking, sir, A loves everyone. But the answer is A does not love everyone. When you say someone loves everyone, then this person should also love himself, herself, because remember, this person itself is in the domain. So when you say someone loves everyone, it means someone in the domain loves everyone in the domain. Understand this. When you say someone loves everyone, it means someone in the domain, at least one person in the domain, loves everyone in the domain. I hope you understood. So this statement is actually false. What about the fifth statement? So let's see this fifth statement. Is this true or false? Here we are saying there exists X for all Y. Again, the same template basically. There exists for all Y. This is the template. We are saying there is someone in the domain such that for every Y in the domain, if X and Y are different, then X loves Y. So notice we are basically saying that you can see the domain of X, that is ABCD. This is the domain of X, ABCD. The domain of Y also ABCD. What we are saying? We are saying that there is at least one fixed person here, such that for every choice of Y, what should happen? This internal thing should be true. Means if X and Y are different, then X must love Y. So notice one thing here. Because of this condition that if X and Y are different, then we have to check that X loves Y or not. Here you can see A loves B, A loves C, A loves D. And this is what we want, that there should be at least one fixed person in the domain of X, such that with every choice in the domain of Y, this internal thing must be true. And the internal thing is basically saying that if X and Y are different, then X must love Y. If they are same, then I don't care. But if they are different, then X must love Y. Yes, you can see I can take here X equal to A. If you take X equal to A, then this fifth statement actually will become true. So this fifth statement is actually true. And who is the witness here? Who is the witness? The witness is X equal to A. You can take. Okay, X equal to A, if you take, then this fifth statement will become true. Very simple. Let's see the sixth statement. For all there exists, this template we already know. For all there exists, there is a song. I told you that whenever you see this template, for all there exists, a song should come to your mind. What is that? Hindi song from Rabata, from Agent Vinod movie, I think, Rabata song. कहते हैं खुदा ने इस जहां में सभी के लिए किसी न किसी को है बनाया, हर किसी के लिए, राइट? Means for everyone there is someone. But remember, for different people, you can have different people. So remember, for all there exist. What this means? This simply means that for everyone there should be someone. These are the elements. Let's assume. Then you can see that for everyone there should be someone. Remember, for this there can be multiple people. That's fine. This is perfectly fine. The point is, for everyone there should be someone. Different people can map to different people. That is also fine. But for everyone there should be someone. Okay. For everyone there should be someone. So you can see this should happen. Very simple. So this is for all there exist. Now you can see what we are saying. We are saying that, notice here something very interesting here. Something very interesting. This is a very tricky question. Notice the Y variable here. And you can see we are basically saying, notice what we are saying. First we have Y variable. Please notice, first here we have Y variable, and the domain of Y variable is ABCD. The domain of X variable is also ABCD, but remember, the X variable we have with there exist. Okay, so this is the situation, that for all we have with Y variable, there exist we have with X variable. Okay, please understand this. For all we have with Y variable, and there exist we have with X variable. And here we have X loves Y. Means the love should be like this. Okay, here we have loves XY. Okay, so what we are saying, see, notice the template is basically same, that for everyone here there should be someone here such that this person loves this person. I hope you are getting the point. See, either you can write like this, loves XY. If you are confused, then what you can do, you can write like this also, that what this actually means, it means that X should love Y. Okay, X should love Y, correct? X should love Y means there should be arrow from X to Y. This is what it means, correct? So here you can see I am saying that the template is for all there exist. For all there exist means for everyone here, there should be someone here such that this person loves this person. Okay, the right person loves the left person. Because you can see this is the domain of X, this is the domain of Y. X should love Y. Okay, means the right person should love this left person. So now tell me, for A, who is there? For A, who is there? Means, can I say for A there is B? But remember, if you say that for A there is B, then B should love A. B is not loving A. C is not loving A. D is not loving A. A is not loving A. You can notice with B there is A. Okay, the love is in this direction. You can see the love is in this direction, X to Y. This is the love direction. Because here we have loves XY. Notice here we have loves XY. This means that X loves Y. X loves Y. Correct? This is the love direction. So here you can notice this is the domain of Y. This is the domain of Y. This is the domain of X. And X should love Y. It means basically the love direction is in this. Means for everyone here, there should be someone here such that the right person loves the left person. Here you can see for B there is A. Correct? For B there is A. For C there is B. For C there is B. For D there is C. Correct? So you can see, but for A there is no one. Okay, the love direction you can see. This is the love direction. This is the love direction. This is the love direction. The love direction is here. Okay, so you can see for B there is A, means A loves B. For C there is B. If you ask D, who loves you? Then C loves D. But no one loves A. Correct? So you can see this sixth statement will become false. Okay, and who is the counterexample here? Who is the counterexample? Because this is for all there exists template, means for everyone there should be someone. But you can see for A there is no one. For A, there is no one to love him. There is no one who loves him. So you can see for A, there is no one who loves A. Okay, so this is the counterexample. I hope you understood. So remember, the sixth statement will be false. So please take care of it. Here, let me just quickly make a diagram here. So what I want to tell you, in the goclass lectures also, I told you this. We have taken many similar examples in the goclass lectures also. So here you can see, if you have, for example, for all X, there exists Y, and then you have loves XY. Okay. What this actually means, here you can see, this is the domain of X, this is the domain of Y, and X should love Y. So remember, the direction of love means for everyone there should be someone, the direction of love is in this direction. For everyone there should be someone, this is the love direction. For everyone there should be someone, this is the love direction. Correct? But notice another possibility is like this, that for all X there exists Y, then I write loves YX. Loves YX. But you can see here we have the domain of X, the domain of Y. And remember, for every X, there should be some Y. Whatever X I take, there should be some Y, such that the love direction is that from Y to X. The love direction is from Y to X. Means the right person should love the left person. So you can see for this, let's assume this person is there. For this, actually, let's assume this person is there. And for this, you can see this person is there. So here what we will say that this person loves this person. The love direction is basically here. This is the direction. This is the love direction. Okay, I hope you are getting the point. Here, two more variations can be possible. For example, if I write for all y there exist, okay, for all y there exist x. These are two more variations. For all y, I can write like this: for all y there exist x, and here I can write loves xy. And another possibility is for all y there exist x loves yx. Okay, so I'm just telling you that take care. Okay, I'm just telling you that take care, that who is loving whom, love is in which direction. Okay, so I hope you understood. So this sixth question, this is another, I can say this is beautiful question. I hope you understood this. Let's solve the seventh statement. This statement is true or false for this diagram. Let's check. The template is for all there exist. Here you can see this y is with for all. For all is with y, and remember there exist, that is with x. And what we are saying? We are saying that for every y there is some x such that x and y are different and x loves y. Okay, basically here you can see what we are saying. We are saying that for everyone there is some x such that x and y are different and x loves y. Okay, so basically this simply means that for everyone, here we are basically saying that for everyone, for every y, or I can say for everyone, there is someone different. There is someone different. Okay, so you can see for everyone there is someone different. Here let me write here that for everyone y, okay, whatever y I take, for everyone y there is someone different than y. Okay, this is what I can write. So let me write it here. For everyone y there is someone different than y, such that such that this is someone, basically someone x. Okay, such that x loves y. Means for everyone there is some different person who loves this person. Okay, so here you can notice, is this true or false? This is still false, because look at a, there is no one else who loves a. Okay, basically, okay, let me just write like this. In simple words, if I say everyone is loved by someone else, everyone is loved by someone else, this is much better way to write it, much natural way to write it. Everyone is loved by someone else. What do you think? This statement is true or false? This is what this statement is saying, that for everyone, for every y, there is some x such that x and y are different and x loves y. Okay, so here you can see that for everyone, everyone is loved by someone else. This is what I can say. This is English interpretation of this expression. Now you can see, can I say everyone is loved by someone else? The answer is still false. This is still false, because you can see that B is loved by someone else. Yes, B is loved by A, D is loved by B, C is loved by B. But you can see A is not loved by anyone. Who is the counterexample here? The counterexample is still A, because you can see A is not loved by anyone else. A is not loved by anyone else. Okay, so remember this seventh statement is still false. Let's see the eighth statement. Is this true or false for this diagram? The template is there exist x for all y. There exist for all. That is the template. So you can see we are saying that there is at least one person in the domain. There is at least one person such that for everyone, what should happen? X does not love y. means there is at least one person who does not love anyone. This statement is saying that there is someone hates everyone. I can say like this because remember, we are basically saying that there is at least one person such that for everyone X hates Y. I can say X does not love Y. It means I can say X hates Y. Okay. So you can see, I can simply say that there is someone who doesn't love anyone. I can say there is at least one person, there is someone who doesn't love anyone. Okay, for all Y, I can say that X does not love Y. So who doesn't love anyone? So tell me, is there any person here who does not love anyone? Yes, D does not love anyone. So this statement is actually true. Correct? Because D does not love anyone. You can see. So who is the witness here? This statement is true. Who is the witness? Who is making it true? The witness is D. Because D does not love anyone. D does not love himself also. If there is a self loop on D, if D loves D, then the answer will be false. Because remember, when you say there is someone who doesn't love anyone, it simply means there is someone in the domain who doesn't love anyone in the domain. Please understand that there is someone in the domain who doesn't love anyone in the domain. So here you can see the witness is D. D does not love anyone. I hope you understood. If you did not understand, so you can do like this. Notice this is there exists for all Y template, right? This is the domain of X, A, B, C, D. This is the domain of X. You can see the domain of Y, that is also A, B, C, D. Now, here we are saying negation of X loves Y, right? It simply means that X does not love, it should happen that X does not love Y. It should happen, right? X does not love Y. So tell me, this is there exist for all Y template, means there is at least one person here, there is at least one element here, such that for every element here, this must be true. This is the meaning, yes or no? There is at least one element here, such that for every element here, this must be true. So you can see, if I take A, then you can see, if I take, for example, AB, then actually this will not be true. So remember, I cannot take A. You can see, if I take C, then if I take, this CD with C, if I take D, then you can see this will not be true. But you can notice, I can take D, this fixed element D I can take, and you can see that if I take DA, DB, DC, DD, then you can see this is actually true. That if I take X equal to D, basically if I take X equal to D, then you can take any Y. Y can be A, B, C, D. Correct? Y can be any of them. Then you can easily see that this statement actually will be true. That D does not love A, D does not love B, D does not love C, D does not love D. So finally, I can say this statement is true, means eighth statement is true. Okay, I hope you understood. So that's it. We have completed the analysis of this question. Now, Stanford has given official answers also. So you can pause and you can read this. You can see this is the explanation of first and second question. This is the official Stanford explanation of third, fourth, fifth. This is the official Stanford explanation of sixth, seventh, eighth. You can see the answer is also given, the explanation is also given. Okay, so you can read it yourself. You can pause the video, you can read it yourself. But we have done the complete analysis of this question. This is a beautiful question, and there are total 8 parts. You can see these are the 2 parts we have seen, these are the next 3 parts that we have seen, and these are the last 3 parts that we have seen. So total 8 parts are there. All those 8 parts we have seen. Please tell me, did you like this question? Let me know. Did you find this question helpful? In the Stanford resources, there are many questions based on this template, different questions based on this template. Our yesterday's DPP, The last DPP, that was also based on the same template. Those were easier. If you remember, our last DPP questions were easier than these questions. So that was those questions. The last DPP questions were also based on the same template from the Stanford University. Today we have done a different question based on the same template. In the future DPPs also, we will keep doing. Basically, we will solve all the questions that I have found in the Stanford resources based on this template. Each and every question we are going to solve in the future DPPs. Okay. So in the future, if such question comes in the gate exam, then you will feel very comfortable. All small things, x and y referring to the same element, this type of corner cases you don't miss. That is what we are making sure. Okay, so once we are done with all the questions based on this template, once we are done with them, then it will be like a good revision of the first order logic. You can see you are basically revising nested quantifiers, you are revising universal quantifier, existential quantifier, implication by implication, everything is getting revised. The complete first order logic is getting revised along with propositional logic, the by implication, implication, all these things we are revising basically. Okay, so based on this template, all the Stanford questions we are going to solve in the future DPPs also. I hope you understood, and I hope you enjoyed this session, the analysis. So remember, if you found this video helpful, the analysis, these questions, the solutions, everything, if you found helpful, then please like, please put a comment, please share your feedback, and please share this video with all the GATE CS, GATE D aspirants. Your support will decide the future of our YouTube DPP series. Please show interest. If you show interest, if you participate, if you encourage us with your comments, likes, and share, then we will continue this series daily and we will bring new unseen standard questions to solve. All these questions will be within the GATE syllabus. All these questions, their difficulty level will be within the GATE difficulty level. So it is a good series for practice, for revision also, and all these are good questions. These are not trivial questions. These are good questions from the standard, from the top university, or I can say from the standard resources, to make sure that you solve the top quality questions. Okay, so thank you everyone. I hope you enjoyed this session. Now you can find the next DPP in the playlist. So I told you that this playlist is there. The next DPP you can find now. If you search on YouTube GATE CS DPP, then goclass DPP video will be shown, and here you can see this link, GATE CSE GOT DPP series playlist link you can find in this playlist. In this playlist, I have already put the next DPP, means the day 8. Today we have done day 7. The day 8 DPP you will find just within an half an hour. Okay, just give me half an hour. I will put that DPP, the day 8 DPP, I will put in this playlist. Okay, just within half an hour. So you can see. So GOT DPP series, the complete playlist link you can find in the description, also in the pinned comment. So check out this playlist. Okay, you can bookmark this playlist. In the future, sometimes what I will do, sometimes I am going to do this, that sometimes I will put a question in this playlist, I will put, but I will not put in the video section of goclass YouTube channel. Sometimes I will do this because what is the reason? The reason is maybe that question is already available on the goclass YouTube channel. That is the reason sometimes I may add that question in this DPP playlist. So please check out this playlist, bookmark this playlist. Every day you open this playlist one time, find the question, solve it. Because this DPP series will go daily, every day. There will be no off days. Even if I'm on holiday, if I've taken, let's assume, 2 or 3, 4 days leave, then also remember, I will pre-record the DPP questions, I will pre-record the solutions, and I will put in this playlist. So please check out the playlist and bookmark it and follow it regularly. Okay, we are not going to miss any day. There is no off day for our YouTube DPP series. Okay, so thank you everyone. Please show your support, like, comment, share with any social media platform that you use. Please share the word of goclass YouTube DPP series. Please share it with the GATE CS, GATE D aspirants. Okay, thank you so much.